Historically, building a decentralized application required developers to manually write, audit, and wire together every smart contract and off-chain indexer. This role is changing. You can now operate as a high-level system architect, defining structural constraints while AI agents translate those requirements into code. To see how this works in practice, we are going to build a cross-chain automation application and deploy it live on the Flare Costin 2 testnet. Our application logic is straightforward. The system monitors the XRP Ledger for a specific payment. Once that payment is verified by the network, it triggers an AI-driven smart account on Flare to execute a predefined strategy. To begin, you will need an AI coding agent like Cursor, Node.js, and Foundry, along with your basic environment configurations. By utilizing this architecture, the application moves away from relying on unverified API states and instead utilizes undeniable cryptographic evidence to trigger its actions. Step 1 is linking your local AI agent to Flare's developer hub. We use the Model Context Protocol, or MCP, server to give the agent access to real-time documentation and interfaces. From the terminal, we use the skills.sh utility to install domain-specific knowledge. Commands like npx skills add Flare general provide the AI with the precise instructions needed to interact with Flare's protocols. With the agent properly context-aware, we use a natural language prompt to instruct the AI to autonomously scaffold a new Foundry project using that Flare general skill. The AI handles the background execution, cloning the repository, creating directories, and automatically configuring the Foundry environment according to our requirements. We ensure the AI sets the EVM version to Cancun in the configuration files, which is necessary to support the network's required cryptographic operations. By integrating the MCP server and specialized skills, the AI functions as a domain-aware Flare engineer rather than a generic coding assistant. For the smart account to operate securely, it must act only on facts that are cryptographically verifiable on-chain. This diagram illustrates the Flare data connector. We prompt the AI to write a module querying the verification interface to confirm XRPL payment proofs. The connector utilizes decentralized validators to achieve consensus on external events, like an XRPL Ledger transaction, before making that data canonical. Next, we instruct the AI via the Flare FTSO skill to integrate the Flare time series oracle, allowing the contract to securely fetch current XRP to USD price feeds. The resulting Solidity code includes the necessary imports for the FTC verification interfaces and the Oracle price registry. Embedding these verification primitives directly into the contract logic protects the application from data manipulation and front-running attacks. With the smart contracts secured, we now build the off-chain triggering mechanism that initiates the automation from the XRPL side. We use a prompt with the facets and smart account skills to generate a TypeScript script designed to manage the cross-chain registration. This script first reserves a unique minting tag and binds it to our specific recipient smart account on Flare. Finally, the script constructs and submits the actual XRPL payment transaction, carrying the required execution instructions in the transaction's memo field. This off-chain logic forms the bridge, turning an action on an external network into a verifiable cryptographic trigger on Flare. To test the system's security, we prompt the AI to write an adversarial test, simulating an unauthorized caller attempting to exploit the smart account. We execute the forge test command. If the execution path fails and generates a raw stack trace, we use that data for the next step. We paste that raw failure trace back into the AI. The agent conducts an audit of the execution path and identifies the failing instruction or gas bottleneck. The AI then proposes a fix for the underlying logic, allowing us to rerun the tests until the system invariants are satisfied. Once the tests pass, we use the forge script command to broadcast our verified contracts to the Costin 2 testnet. This autonomous cycle reduces manual trial and error, ensuring your logic is rigorously evaluated and optimized against adversarial conditions before it ever touches the live network. We have now successfully deployed a proof-backed cross-chain AI execution system on the Flare testnet. In this workflow, the human defined the architectural boundaries and security constraints, while the AI managed the implementation details. By utilizing Flare's enshrined FDC and FTSO protocols, we've built an automation system that relies on decentralization rather than assumptions. This poster details the Flare Summer Signal Hackathon. You can apply these AI-native workflows to build interoperable asset products or privacy-preserving applications for the $12,000 price pool. Developers can also participate in the Verifiable AI Hackathon to build autonomous agents that interact with Flare's DeFi ecosystem. Decentralized development on networks like Flare is rapidly evolving into a new discipline of architecting verifiable, autonomous systems.